Dave Wallom. I'm going to be talking about user engagement in the Federated Cloud and how that drives our need for interoperability. I'm actually giving this presentation on behalf of Diego Scardacchi, who was unfortunately stuck by Italian Airlines not interoperating because they cancelled his flights yesterday and there weren't any replacements. So here is the EGI Federated Cloud in another architecture diagram. But the important part here is obviously the standards, the various standards that we're using for the interconnection of the cloud management frameworks that we support. And these were the three that you've heard about today, but obviously then through Rocky and other types of services that Boris mentioned earlier, we have a wide variety of other cloud systems that we're able to connect to. The support for OCCI and even for CDMI, though, in some ways for connection to the Federated Cloud, is only one part of the problem. The other part is, first of all, this side at the standards level. So we've looked towards OVF in the longer term as our standard for virtual machine images, so that we are able to have interoperability and very easy movement of VM images onto the different platforms. We also have a standardized method of information publishing and information discovery through the GLUE2 standard and through OGF. We support basically utilize a number of GSI-capable plugins for our federated AI. We have a Nagios-based monitoring service and accounting through, again, an OGF standard, the usage record, and in the longer term also through the STAR record, the storage accounting record, so that we're able to actually look at the utilization of all of our different services. Because one of the things that it struck me even today is actually that cloud, everyone talks about cloud as this bit. And everyone forgets about cloud and certainly infrastructure as a service with storage. And from that point of view, Stephen, he's got petabytes, so he can't forget about storage. But even he doesn't make it available, he's not making a CDMI interface available onto his resources, or an S3 service. His is still connected to locally available virtual machines. Yes, Stephen?
So we do use an object store internally. It's exposing that as with an S3 interface is a discussion that we might have in collaboration with, say, CERN and others. If somebody provided a CDMI interface,
yep,
then we might want to start
talk to the groups. So their reference implementation of CDMI is a standalone service, so talk to the Greeks.
Might have to.
Yep. But the other part of all of this federation, and the bit that I'm going to be concentrating on today, is not the purple bit, it's not the orange bit, it's not the red bit, but it's the green part. It's the personal services, because actually through this side, our provision of help and support, our interaction with our user communities, it drives actually what we develop up here. There's no point having interoperability if your user community doesn't want it. So I'm just going to quickly go through actually how we provide help and support, how we interact with our users, and actually what we've done in terms of success from the point of view of actually providing services to different communities in an interoperable manner. So we saw a greatly more complicated version of this diagram in the talk from Christos and Panos. But the important part here is to first consider, actually the actors that are involved here. We've got our technical developers. We've got the people that actually develop our virtual machines for the different communities. These are many and varied. They may take them, they may pull reference images from other sources. They may take things, for example, in the environmental omics community, they may take the BioLinux image. So these guys may not actually be anything to do with the federated cloud at all. But they're actually, the virtual machines that they provide are endorsed by our virtual organization manager, so that our different cloud providers are able to have some trust, some faith in the images that they're actually installing on behalf of a specific community. Our end users, or what we term as our VM operators, are those that instantiate virtual machines. And from my point of view, they're the only group at the user end really that matters. I don't really care who uses the services that these people provide. Because as far as a resource provider is concerned, they are the only people they see. You know, your cloud site will only ever see the end user who instantiates a VM. If that service that's contained on it runs whatever, and different users come onto it, no one's going to see that. So from our side, you know, these are the guys that are interacting with the clouds through the OCCI API itself, maybe incorporated into an application, or through some high-level services that I'll talk about later on. From the point of view of actually how we help our user communities out, because this, of course, is, no matter what anyone says, it's not a simple environment to exist in. Excellent, Stephen's leaving. I can now say what I want about EGI. From the point of view of actually providing simplified information to our users is a very important part, particularly where we're starting to try and ask them to think about their use of different standards, different tools, and the developers in these communities, how they get information about the different interfaces and different services that we provide. We've been working for a number of years to actually ensure that through the Federated Cloud Wiki on the EGI service, that we have a single point of all information. Now this is a really important thing, and examples of this have been different communities that have come along and actually implemented different connectors to some of our standards, to some of our clients and even some of our servers, but have done it by actually connecting in and looking at the information that we provide first. You know, the guys from Apache Cloud Stack, for example, looked at our documentation and started integrating Rocky for the first time round just from our documentation. So from that side, this is an incredibly important thing that we make sure that we have up and supported. So just to blow out the contents, you know, how to use the Federated Cloud Access guides, tutorials, so that we can actually start thinking about how to upskill some of the user base. Because no matter what anyone says, the users themselves do care about what they're actually doing. They do care about what they're using. And if you provide the information to them in a way that relates to how they may use a service in the future, they will actually make better use of it than they would do otherwise. The very important ones there, of course, though, is also around user support. And that's technical user support. That's also help desk services, because where we are using interoperable clouds from multiple different providers, it's an awful lot more complicated than if you just go and log onto the Amazon, the AWS website and just go, oh, well, instantiate me a VM. You're talking about orchestration, even if it's manual orchestration, almost from the get-go. And from that point of view, the need for contextualization that was mentioned in the earlier presentation, so that you can actually get different virtual machines that are instantiated on different services to talk to each other, is very important. As an example of where we are in terms of some of our documentation, you know, setting up our command line clients, making sure that everything is well documented there, but also then how to start using some of our higher level environments. You know, we do have a number of users that are sitting at the similar groups that Boris mentioned earlier, that instantiate a single VM on a particular resource, use it, maybe leave it running for a very long time. But we also have a number of users that build complex multi-site services that instantiate different types of component on different types of resources to really make use of some of the services that are available. The applications database that was mentioned earlier on is really our starting point, though, for how these complex services can actually be deployed. Because we associate a different image, a different instance, or a different cloud pack as we move to more complex services with a different virtual organization, they can be automatically uploaded onto different cloud resource providers that are supporting the different services. The types of applications we're actually supporting at the moment, we talk about, services to support app development, large-scale deployment stacks, big data services, we had to get the buzzword in there somewhere, all the way down to, what you want a specific operating system for a particular tool that you've deployed onto it. So these higher level tools, I mentioned it 3 or 4 times, these are the guys that allow you to really abstract away from any one of our particular cloud deployments and start thinking about, scheduling what you do, orchestrating what you do onto multiple services using multiple providers. Infrastructure as a service is very much a bottom layer. Our user communities, many of them are starting to think about more about moving up the stack. We want to provide an alternative to just the OCCI clients, mainly because actually there's an awful lot more functionality out there. And the average user, when he starts seeing the functionality that's totally available from the OCCI interface, if they try and use the command line, will get themselves massively confused. So we want to actually give them some more easy to use services, something that maybe looks a bit more GUI-like and they feel more comfortable with. The different types of these high-level services, infrastructure brokers and application brokers we've got there, are shown in that list of 5 there. And I'm going to start in some ways from the bottom. So here, this is actually a workflow language that supports its instantiation of workflow components using OCCI onto different cloud environments. VM Dirac allows you to really ignore whether a resource is a cloud, a grid, an HPC cluster, and just think about it as a resource that can run a particular part of an application or service. Comps is a Comps Supercalar. It's actually been developed by Barcelona Supercomputing Center, and I'll say a bit more about it later on, but actually as an API, as a library to include in a piece of application software. So this is something that you very tightly bind into the underlying applications of your user community. Slipstream is around orchestration and looks much more like a tool that you would actually see or recognize from something like Amazon or AWS or VMware or something similar. It is a commercial piece of software, but it's one that has an open source branch to the main subjects of its components and OCCI implementations, alongside other connectors for different types of cloud management framework. And then the Catania Science Gateway is I suppose the overall way that we actually provide software as a service frameworks to our different communities, software as a service environments. So here is the Catania Science Gateway. It's provided through a project called Chain Reds, which is another group within Europe that are doing federated cloud. And the idea is that effectively it can abstract out entirely what's happening inside a particular workflow, a particular application, and provide it just as effectively as a web application. So that you can actually see, from a user point of view, it's all pre-configured, it's all preset. It uses under the hood a number of different standards, so it uses Rocky, it uses CDMI, it also uses JSaga, and has been working very closely with the Saga team to actually support that, which is another standard from OGF from many years ago. In terms of what we actually provide for the users themselves, this is it. This is to launch the Octave application. It allows you to actually specify completely what is actually going to be run in Octave when you instantiate it, and it allows you just to provide effectively application launchers, simplified to the community so that they have a very quick and easy way to do things. So moving on from sort of some of our services, what about our people? How do our people work in this? We have a fairly large set of user support teams within EGI in a number of the national grid infrastructures, or NGIs, around Europe. All of these countries are members of the EGI Federated Cloud, so their national teams have bought into this. And our aim is really to actually work with a use case very closely so that we can, in greater detail, work out what their requirements are. Where are they wanting to use things on multiple different cloud frameworks? Where are they wanting applications or compute to be near data? What is the most efficient placement of their data? And from the technical point of view, this also then gets fed back into the technical development team that's located in the Federated Cloud Task Force. So we here have our users, our support team, and our technical development working in close, coherent partnership so that we actually have very quick turnaround if new features are required, etc. So how does this actually work? Well, the first one is obviously we meet the group, meet the guys, meet the user team. We then start looking at and calculate and working with them to see exactly what support they want. And that might be, working first of all to set up a new virtual organisation. We then look at the particular developments that they may require. And then we look also at the way that we can use what are known as virtual teams to actually bring together different communities that have very similar technical problems. Finally, we all want to see, as the Federated Cloud is a production service in EGI, we actually obviously want to see the use case actually become a production use of our cloud. And from that point of view, that also means that we need resource providers to commit that they're going to support a certain user community with a certain set of interfaces for a certain length of time. And that's we're aiming is through legally enforceable service level agreements that do include things like we will provide OCCI interfaces for the next 2 years to our cloud, irrespective of what our cloud management framework may be. We are going to provide development support to the different user communities. So what are our user communities? And this was this is a fair representation, but not all of them now. And you can see that in comparison to the grid, we've somewhat branched out from high energy physics. High energy physics is still there. We are working closely with CERN through the Helix Nebula activity to support Atlas processing. We've also very, very recently started supporting CMS. But when we look back up this list, we've got software engineering, we've got computational linguistics, structural biology, earth observation, musicology. And the other part that you should notice here is actually that though many of these are academic or research cases, Peachnote is actually a commercial company. So we're actually starting to think about supporting commercial organisations on this federation. Since we launched in May, we've also had our first use case, and I haven't seen this from anyone else actually, of guys that want to use the Federated Cloud for teaching. So these are people that are integrating the access to resources and also our underlying infrastructure into teaching. So when they're teaching distributed computing at Cranfield University, they get to run on the Federated Cloud, and they also get to look at under the hood and see how we've built the Federated Cloud. We've also a number of different and new communities. We heard this morning, for example, of the IT as a network, IT as a utility. So the Internet of Things activity from looking at smart grid systems, bioinformatics, Stephen Newhouse's Elixir, for example, that was mentioned earlier on. So here in some further detail is some of our use cases. So the WNMR is a structural biology community who are looking at the fact that with the vast volumes of data in a high throughput way that they receive, how they can distribute out the resource processing that they need to do onto multiple different cloud frameworks. And here we're actually running onto 2 different types of cloud platform. So we're running onto Open Nebula, and we're running onto OpenStack, and we're providing the users with a customized OCCI client, which is basically their own software built onto the OCCI library. So moving on from, so this was the Helix Nebula flagship for the European Space Agency, and this is about automated cluster deployments using their GPOD system, which is grid processing on demand. And the idea here is that actually you can deploy into the federated cloud and orchestrate together a cluster across multiple different resources, which may have various data affiliation with some parts of the processing workload, as parts of the work stream, and allows them to basically create clusters just when they need to deploy resources. You know, when they get a particular request for resource, they can fulfill it. In some ways very similar to how the guys at NASA have done with the Mars rover with Amazon and EC2. The idea being that it's processing when you need it, not continually having bought millions of pounds worth of equipment. I mentioned Peachnote, and I mentioned Peachnote very specifically because actually their largest usage of the federated cloud, apart from deployment of small-scale worker nodes, is actually to act as the repository for the storage of their underlying library. So these guys have effectively created, as they call it, Google Books for music scores, so that you can go in and search for a particular phrase of music, phrase of music text, and it will then show you the results of all the music they have in their repository that matches that. So if you have bing, 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 bong, then you can actually search for that and see which pieces of music have that in. It's very interesting, used very much by the copyright industry, actually. From the point of view, there's a huge, music phrases are actually part of the copyright, and so people get very, very defensive about their IP. So I mentioned earlier about the comp superscaler. So that's a workflow orchestration down here that operates at the API level. And here, this is the Open Modeler service for the BioVel community. And here, this deploys large-scale Taverna workflows. And you can see each of these coloured boxes is a subcomponent of the workflow, which each then get automatically distributed onto the different nodes in the federated cloud. There, they can also, through the Taverna system, specify restrictions and, or underlying requirements on where certain pieces of the processing need to go. That might be, as Stephen mentioned earlier, that you've got human subject data that can't leave EBI. Well, some of those bits of that workflow can run on EBI, and then the data be passed across the different members of the federated cloud. I mentioned Chain Reds earlier, and the main reason I did that, because they are another Cloud Federation project, is actually that through their the Catania Science Gateway, we've actually got it so that they can run on any of the cloud services that they themselves have within Italy and within China, but also then in parallel on the federated cloud. And we're supporting them the other way around, so that we're starting to see whether or not we can get access to some of their resources and bring them on board into the federated cloud as well. So how do we actually manage our user communities? Because we've got a fair number now. When we were the grid, we had handfuls of users. That was quite easy to manage, quite easy to control. Well, the reality is now we don't have handfuls; we have very large numbers. And the idea is that we effectively have a very, very tightly controlled and monitored workflow where we actually assign a different expectation on our users as they move through this from pre-assessment, so actually looking at what information can we get from them, what do we actually need, what are they looking for in terms of capability, then working with the user community team, thinking about running test services, making sure that what they're expecting from the federated cloud is what they're actually going to receive, right the way through to production. This is now actually a core part of a particular community's activities. The BioVel guys, for example, that's now a core part of the sustainable BioVel services. So they're actually using the federated cloud 24/7 in a production environment. we also recognise that some of these tests might just go through to completion. That might mean all they were looking at was looking at whether or not the cloud was really a way that they wanted to provide that. Interesting enough, we've never had anyone cancel on us, which is always quite nice to know. So everyone is, we're moving all of our user communities through that workflow. So virtual teams. So virtual teams are a way of bringing together people from multiple different groups to really link them together, and that's multiple different countries and multiple different groups, I should say. And the aim, really to bring people together. And here I'm going to use the genome analysis and protein folding group as an example. They've got a number of different tools that different parts of the community have brought in, where all of them would want these tools to be there, but each specific member of the community said, right, well, we will look at this particular tool, we'll work it all the way through, we'll create instances within the applications database, we'll test and make sure that they work on the different platforms. So here, this is redemption, and really, to be honest, it's a workflow, but it's really based on R. But what we now have is located within the application database, the redemption VM, which has a preset so that it's a useful amount of computation, and it's able to be distributed and run onto various different resources. There we have IFCA, GWGG, and SESNet are resources that have stated they'll support this, but it's available just beyond just the community that originally requested it. Our aim here is to share workflows, share services, share virtual machines. Unless
so how is access to all this managed within a virtual organization, or is that even a valid question? Or how does the term virtual team relate to virtual organization?
Right, virtual team is a support unit terminology to bring together multiple people from different communities. It may be supporting multiple different virtual organizations, but they all have an underlying request. The different teams that were in the genome analysis and protein folding virtual team, multiple of them actually were using redemption. And so one of the groups said, right, we will handle getting this onto the federated cloud, we will handle the packaging of it, we will get the agreement with the resource providers to support it, so that we weren't doing this multiple times, so we're not replicating work more essentially. The other one from the Elixir guys was Chipster, which is again, this is about next generation sequencing and proteomics processing. And the idea here is again, create the virtual machine template, get it set up, get it deployed, get it tested, because this is the other part. What we don't do is we ourselves do not manage long-term the virtual machines that are in the AppDB. That is the responsibility of the owner of that image. And so from that point of view, getting the testing framework set up so that people can actually know that when they deploy a Chipster VM, it's actually going to work because it's being maintained and it's being supported is a very important thing. So, just coming towards the end, because it's getting late. Yeah, so we've got 28 different communities with nearly 50 use cases at the moment. That's 50 documented use cases of how we've used multiple federated cloud across normally more than one infrastructure, using more than one underlying cloud management framework. Directly, 22 of them use the Rocky client itself. The interesting thing here is, we've got another 12 that are using the high-level brokering tools. 7 of them from private companies, from actually outside of the academic research space, which is an important branching out for us, bearing in mind the European Commission's target for support for SMEs. From the point of view of actually how we measure our impact, which is a very important thing these days, we ourselves have also done a little bit of a split on who's using our cloud. We're quite big in the natural sciences, you could say. But if we look further down in that, look at a sort of lower tier of classification, we're fairly well distributed. But again, biological sciences really jumped on the cloud bandwagon very, very heavily.
By the way, you shouldn't go past that slide so fast. This is success, right? There's years chasing this.
Oh, sorry. That is success.
Well, yes.
So, sorry. That's success. That's nearly an order of magnitude more communities than the grid had nearly 10 years after it was started.
Yeah, we spent years trying to figure out how can we pull in these communities. And
Yep.
as soon as we changed to this technology,
Well, so the conversation I had with Stephen at lunchtime was very clear about this. The one thing the grid never did was it never gave users power.
Right.
The cloud gives users power and control,
Right.
and that's what they want.
That's what they want.
Yeah.
So, yeah, I know, I mean, on your earlier slides, you had Earth observation
Yep.
listed twice, and you know that I chased that community for quite a while
Yep.
to try and
So the where are they? Let me just
coordination.
go.
I know that, you know, again, Open Geospatial
Yep.
Consortium, in their current test beds, in their last test bed as well, they had a cloud adoption,
Yep.
whatever type of thing, and, you know, I still think that there has to be a lot of overlap there. It's just somehow a question of getting these communities together. And
Well,
specifically with regards to folks in the that probably hang out at the EGI of the European Geophysical Union.
Yeah.
Yeah.
Yeah. So I should say, you know, my own personal projects are also looking at using the EGI Federated Cloud. I support all of the technical infrastructure for a large-scale volunteer computing project, and we've got a production use case for that where we need to guarantee resource returns within a number of days. We're going to be using the Federated Cloud there. So we're seeing different types of current usage of e-infrastructure in other areas migrating towards the cloud. So just to finish up, because you know, I should finish really. You know, scaling up our support and outreach has been one of the big challenges for EGI. I think because historically for so long, its support and outreach was at the scale that was required for grid. You know, maintaining and managing the 33 active use cases that we have at any one time now is quite a stretch for our user community support team. So that's been a really, really big challenge for them. One of the things that makes this very important, though, you know, is the drive towards self-service. You know, the more you have to actually handhold a community or handhold a team, the harder it is. So we need to become more cloud-like. That's why we're sending Boris to the security meeting on Monday, so that he can point out to them that we want to be like Amazon and self-service, and we don't want to be like grid security because it's just too intrusive. You know, we need to be open and flexible. You know, we need to be able to be able to support different communities in different methodologies, supporting different application design models. High throughput computing is very good. It's used by a number of communities, and that's what we've done in a number of different areas. You know, we've got a number of different communities also that are supporting database as a service inside their instantiation, their virtual machines. We've got a number that are supporting long-lived services as well, portals, applications, this sort of thing. And yeah, we are working, the Federated Cloud Task Force and the user community now works very, very closely together because I run them both. Thank you very much. And if anybody has